Hello guys, so we are going to continue the discussion with respect to statistics. In this video, we are going to discuss about types of probability distribution. Already in our previous video, we have already seen about PDF, we have seen about PMF, we have seen about CDF, right? We saw with multiple examples, we saw what is the relationship between PDF and CDF, what is the relationship between PMF and CDF. Now, whenever we work with a data set, guys, we may have many features. It may be like we may have a random variable like ages, we may have like weight, we may have, let's say, like salary. So these all are some random variables, right? Let's say ages may follow some kind of distribution. So this is the distribution that ages may follow, right? If I probably consider about salary, salary may follow this kind of distribution, right? There may be weights may follow this distribution again, right? If you probably work as a data scientist or a data analyst, there are real number of chances is that whenever you get a data set, this data set usually follows different, they usually follow a different distribution, right? And there are some set of distribution that everybody should know. Set of distributions that everybody should know, right? And that is what we are going to see in the upcoming series of video. What are the different kind of distributions specifically with respect to our data, right? So let's consider, right? And the types of probability distribution of data that we are going to see is number one, right? We'll be talking about something called as Bernoulli distribution. So Bernoulli distribution over here, here the outcomes, if I probably talk about the Bernoulli distribution, here we'll be working with data where the outcomes are completely binary. They're only binary. That basically means your value can be zeros or one. One example that I can probably say is tossing a coin. And to construct the distribution, we have to use a PMF function, because when I say outcomes are binary, this is nothing but it is a discrete random variable, right? Discrete random variable. And whenever we have a data set, let's say I have a data set with 10 features, one of the feature can follow Bernoulli distribution. Second one that we are going to probably see is something called as binomial distribution. So this is also a very important distribution that you will be seeing. And binomial distribution is also it is for the discrete random variable. So here also we are going to specifically use PMF. Okay. Let's talk about another distribution, a very common distribution that most of the data set follows, which is called as normal or Gaussian distribution. And this distribution specifically is created with the help of PDF, that is probability density function. And just one example, if I probably consider your distribution which has this kind of bell curve, this is nothing but it is a normal or Gaussian distribution. Now, why this distribution is important? Because based on this distribution, there are some set of properties or assumptions that this distribution will follow. And because of this, we'll be able to assume that particular assumptions and we'll be able to train our model much more efficiently, right? Even with respect to data analysis for the data analyst, this will be very helpful. Okay. Coming to the next distribution, right? Let's talk about this particular distribution. The fourth distribution that we may be discussing about is something called as Poisson distribution. Poisson, I'll not say poison, but Poisson distribution. So in this also we will be constructing PMF. With the help of PMF, we basically construct this entire distribution. One very common distribution that is available is called as normal distribution. Some of the data set also follows this kind of distribution. I'll be talking about some of the examples over here. And here we basically use PDF because it is for a continuous random variable. Wherever PDF is written, that is for continuous random variable. Wherever PMF is written, that is basically called as, that is for discrete random variable. One more distribution that we will be probably discussing about is something called as uniform distribution, which is again a very amazing distribution. And here you'll be seeing multiple examples. That will be my target. See, my target will basically be to cover as many as distribution and also showcase multiple examples. But why this is really important? Let me just give you an example. Let's say as a data analyst or as a data scientist, you will be given a data set. Let's consider that I have a house price prediction data set. And I want to probably analyze this particular data. Okay. Let's say I have one of the feature like the size of the house. Okay, this is one of the feature. Let's say another feature is number of rooms. Let's say one more feature is that location. Okay, one more feature is that floor, right? Floor number, like what floor you are in specifically. One more feature is that is this near seaside or beach side. Okay, this will be a binomial feature, like the outcomes will be binary, zeros or ones. And finally I have this price, right? Now here you know that every feature, this feature can be a numerical feature. It will be a continuous random variable, right? Continuous random variable, right? Why? Because the values will be continuous. Here it will be discrete, right? If I talk about location, we can convert this into discrete or fixed number of categories. Floor, it will be a discrete number again. I cannot say 4.5 floor or 5.5 floor, right? Seaside, yes or no. So this can be a Bernoulli distribution, right? It can be having values like zeros or ones, right? Then price will be a continuous random variable, right? So if I know, and these all features may follow some kind of distribution, right? Let's say this Bernoulli distribution, I may use a PMF. For this, I will be using a PDF. For discrete, I may go ahead and use my PMF, right? Continuous random variable, I may go ahead and use PDF. Then I will be able to understand the relation. I'll be able to understand the entire distribution. And based on different types of distribution of data, we can definitely make a lot of assumptions. And based on that particular assumptions, it will definitely help us in EDA and in feature engineering, which is the most important step, let's say, as a data analyst or a data scientist. Because at the end of the day, we are just analyzing data. We are able to understand about the data. We are able to create reports from the data, and we are able to send that reports to the stakeholder. This is really important. So in the upcoming series of video, one by one, we will be seeing this entire distribution. And remember, for all this distribution, this f of x function will be different, right? F of x function is basically used to create the probability density function or probability mass function, right? Probability density or probability mass, right? So for Bernoulli distribution, the f of x function will be different, right? Then again, if we just go ahead and take the gradient of the cumulative density function, we'll be able to get the probability density based on this particular function. For binomial, it will be different. For normal or Gaussian distribution, it will be different. For Poisson distribution, it will be different. So we will go ahead and discuss each and everything. So yes, this was about the type of probability distribution. I hope you're able to understand this particular video. I'll see you all in the next video. Thank you.